Take your smartphone out of your pocket. Hold it in your hand, feel the weight of it, look at the screen. To you, this is a tool. It is a way to text your friends, watch videos, and check your email. It feels solid. It feels like a machine made of glass and metal, operating on logic and electricity. But you are wrong. You are holding a box of trapped ghosts. You are holding a device that, according to the laws of common sense, should not exist. A device that relies on particles walking through walls. A device that relies on electrons being in two places at once. A device that relies on the terrifying, mind-bending rules of the subatomic world to function for even a single second. If I told you that you were a wizard carrying a talisman that harnessed the power of the spirit realm, you would laugh at me. But that is exactly what you are. We have this idea that quantum technology is something far away. We think of giant, golden chandeliers hanging in frozen laboratories at Google or IBM. We think of sci-fi computers that will one day solve the secrets of the universe. But the truth is, the quantum revolution didn't start today. It started 70 years ago. And you are living inside of it. Every time you scan a barcode, every time you get an MRI, every time you use Google Maps, and every time you turn on a computer, you are applying quantum physics. We didn't just study the ghosts, we put them to work. If you are ready to see the invisible magic that powers your daily life, if you are ready to realize that you are already a quantum operator, please hit that subscribe button right now. We are about to tear open the machinery of the modern world and show you the quantum engine beating inside. Let's start with the most obvious one, the one that changed human civilization forever. The transistor. This is the brain cell of your computer. It is the switch that turns the ones and zeros on and off. In the old days, computers used vacuum tubes. They were big, hot glass bulbs. They were size of a light bulb, and they broke all the time. Then we invented the transistor, a tiny piece of silicon that does the same job. Your phone has billions of them, billions, packed into a chip the size of your fingernail. But here is the thing, you cannot build a transistor using classical physics. If you treat an electron like a tiny marble rolling down a pipe, a transistor makes no sense. To make a transistor work, you have to understand that an electron is not a marble. It is a wave, and it lives in a world of energy bands. Imagine a cliff. At the bottom of the cliff, you have the valence band. This is where the electrons live when they are lazy. They are stuck there. They can't move. They can't carry electricity. At the top of the cliff, you have the conduction band. This is where the electrons can run free. This is where they create electricity. In between, there is the gap, the forbidden zone. In a normal material like rubber, the cliff is too high. The electrons can't jump it. That's why rubber doesn't conduct electricity. In a metal like copper, there is no cliff. The electrons are already at the top. That's why wire conducts electricity. But silicon is special. Silicon is a semiconductor. The cliff is exactly the right height. If we give the electron a tiny push, a tiny voltage, it can quantum leap up the cliff. It disappears from the bottom and reappears at the top. It turns the switch on. If we remove the voltage, it falls back down. It turns the switch off. We are controlling the quantum state of billions of electrons, forcing them to jump a forbidden gap billions of times a second, just so you can like a photo on Instagram. But it gets weirder. As chips get smaller, the walls inside the transistors get thinner. We are packing them so tight that the barriers between them are only a few atoms thick. And now we are facing a problem called quantum tunneling. Remember, electrons are ghosts. They can walk through walls. If the wall in the transistor is too thin, the electron doesn't wait for the voltage to push it over the cliff. It just tunnels through the wall. It leaks. Your battery dies because the electrons are literally teleporting out of their cages. Engineers aren't just building circuits anymore. They are building quantum prisons. They are designing chips specifically to fight against the tendency of matter to walk through solid objects. So the next time your phone gets hot or your battery drains fast, don't be annoyed, be in awe. That heat is the result of a battle between human engineering and the fundamental uncertainty of the universe. Now let's look at the second technology, the one that builds the internet itself. The laser. You use lasers every day. You scan groceries, you play Blu-rays, you might even have had laser surgery on your eyes. But the most important laser is the one you don't see. The fiber optic network. The internet is not a cloud. It is a series of glass tubes under the ocean, pulsing with laser light. But what is a laser? It stands for light amplification by stimulated emission of radiation. That sounds technical, but it is purely quantum. In the classical world, light is chaotic. Think of a light bulb. It sends out photons in every direction, at every color, in a messy jumble. It is like a crowd of people screaming different words at the same time. A laser is a choir singing one perfect note. How do we do it? We use the quantum nature of the atom. An atom has energy levels. Think of them like steps on a ladder. Electrons sit on the bottom step. If you hit an atom with energy like electricity, the electron jumps up to a higher step. It becomes excited. But it doesn't want to stay there. It wants to fall back down. When it falls back down, it releases that extra energy as a photon of light. This happens all the time. It's how a neon sign works. But here is the quantum magic. Einstein predicted this. If an electron is sitting on the top step waiting to fall, and a photon flies past it, that passing photon talks to the electron. It whispers to it. It says, "Fall now and be like me." The electron falls. It releases a new photon. But this new photon is a clone. It is exactly the same color, exactly the same direction, and exactly the same phase as the first one. Now you have two perfect twin photons. They fly past the next atom. They whisper, "Be like us." Now you have 4, then 8, then 16. It is a chain reaction of light, a cascade of quantum cloning. We trap these photons between two mirrors, bouncing them back and forth, building the army of light until it is so powerful it bursts through the mirror as a laser beam. This beam can carry information. It can carry your emails, your videos, your voice calls. Because the light is so organized, it can travel for miles through glass threads without scattering. Without the quantum understanding of stimulated, understanding how atoms talk to light, there is no internet, there is no YouTube, there is no global economy. We built the modern world by teaching atoms to sing in harmony. Now let's move to something that saves lives. MRI, magnetic resonance imaging. If you have ever torn a ligament or had a concussion or needed a tumor scanned, you have been inside the donut. You know it's loud, you know it involves magnets. But do you know what it is actually doing? It is talking to the water in your body using quantum spin. Your body is mostly water. Water contains hydrogen. The nucleus of a hydrogen atom is a proton. Protons have a quantum property called spin. You can imagine them like tiny little compass needles. Normally, the protons in your body are spinning in random directions. They are a mess. When you slide into the MRI machine, you are entering a massive magnetic field. This field grabs all those trillions of tiny protons in your body and forces them to line up. Snap, they all point north. You don't feel it, but your quantum self has just snapped to attention. Then the machine fires a pulse of radio waves at you. This pulse hits the protons, it knocks them over, it makes them spin sideways. Then the machine turns the pulse off. And here is the magic. The protons try to stand back up, they try to realign with the magnet. As they stand back up, they release a tiny, tiny signal, a radio whisper. The machine listens for this whisper. But here is the key: protons in different types of tissue stand up at different speeds. A proton in your bones stands up fast. A proton in your blood stands up slow. A proton in a tumor stands up at a different speed than a proton in healthy brain tissue. By measuring the time it takes for these tiny quantum tops to stand back up, the computer draws a picture of your insides. It distinguishes fat from water, muscle from bone, cancer from health. It is the ultimate application of quantum mechanics. We are manipulating the spin of the nucleus of the atoms inside your living tissue to see without cutting you open. If quantum physics was wrong, an MRI would just be a very expensive, noisy magnet that did nothing. Now, let's look at something you use to find your way to the grocery store. GPS. Global Positioning System. You have a blue dot on your map. It tells you where you are down to a few meters. How does it work? There are satellites orbiting the Earth. They have clocks on board. They send a signal to your phone with a timestamp. Your phone receives the signal from 3 or 4 satellites. It compares the time the signal was sent to the time it arrived. It uses the speed of light to calculate the distance. Then it triangulates your position. Simple, right? High school geometry. Except for one problem. For this to work, the clocks on the satellites have to be perfect, and I mean perfect. If the clock on the satellite is off by 1 single nanosecond, 1/1000th of a second, your GPS position will be off by 30 centimeters. If the clocks drift by just a millisecond, your GPS would tell you that you are in the middle of the ocean when you are actually in your driveway. Mechanical clocks aren't accurate enough. Quartz clocks aren't accurate enough. We need atomic clocks. An atomic clock is a quantum device. It uses the cesium atom. Remember those energy steps we talked about in the laser? We hit a cesium atom with microwaves. We tune the frequency until it is exactly right to make the electron jump between 2 specific quantum energy levels. This jump is the tick of the clock. It is the most stable thing in the universe. It is the heartbeat of the atom. It never changes. It never slows down. We define the second not by the rotation of the Earth, but by the vibration of the cesium atom. 9,192,631,770 oscillations. That is 1 second. But there is another layer of physics here: general relativity. Because the satellites are moving fast, and because they are far away from Earth's gravity, time actually runs faster for them than it does for us on the ground. It's Einstein's time dilation. The quantum clocks on the satellites tick faster than the quantum clocks on your phone. They drift by about 38 microseconds a day. That doesn't sound like much, but if we didn't correct for it, the GPS error would grow by 10 kilometers every single day. Within days, the system would be useless. So your GPS is a marriage of two theories: quantum mechanics, the atomic clock, and general relativity, the time correction. Every time you find a coffee shop, you are proving Einstein and Bohr right. You are navigating using the bending of time and the vibration of atoms. These are the technologies of today, the ones we take for granted. But what about tomorrow? How are we applying quantum physics to change the future right now? We are moving from quantum 1, controlling groups of atoms, to quantum 2, controlling individual atoms. This is the era of the quantum computer. You have heard the hype, but what does it actually do? A classical computer uses bits, 0 or 1, on or off. A quantum computer uses qubits. A qubit can be 0 and 1 at the same time. It is in a superposition. Imagine you are trying to find the way out of a maze. A classical computer is like a single person walking through the maze. It tries a path, hits a dead end, turns back, tries another path. It does one thing at a time. If the maze is huge, it takes 1,000,000 years. A quantum computer is like pouring water into the maze. The water goes down every single path at the same time. It finds the exit instantly. This isn't just faster, it is a different way of thinking. Right now, today, companies are using early quantum computers to simulate molecules. Think about drug discovery. To invent a new medicine, we have to know how a drug molecule interacts with a protein in your body. But molecules are quantum objects. They are complex clouds of electrons repelling each other. A classical computer sucks at simulating this. It creates a rough cartoon. A quantum computer can simulate the molecule perfectly because the computer itself works the same way the molecule works. It speaks the same language. We are on the verge of designing new materials, new batteries, and new cures for diseases that were previously impossible to model. We are using it for optimization. Traffic flow in a city, supply chains for global shipping, financial portfolios. These are problems with too many variables for a normal supercomputer. But for a quantum computer, it is just a probability wave to be collapsed. And then there is the dark side. Quantum cryptography. Right now, the security of the internet, your bank account, your passwords, national secrets, relies on math. It relies on the fact that it is really hard to factor large numbers. A classical computer would take 1,000,000,000 years to crack the encryption on your credit card. A powerful quantum computer could do it in seconds. This is the quantum apocalypse, the day when all secrets are revealed. But don't panic yet, because quantum physics provides the shield as well as the sword. We are building the quantum internet. Using quantum entanglement, we can send information that is physically impossible to hack. If you send a key via entangled particles and a hacker tries to look at it, remember the observer effect. The hacker is an observer. By looking at the key, they change the key. They collapse the wave function. The receiver immediately knows they are being spied on because the data arrives corrupted. We are already using this. Banks in Switzerland and voting systems in some countries are already testing quantum key distribution. We are building a world where privacy is guaranteed not by laws, but by the laws of physics. And finally, let's talk about quantum sensors. This is the tech that will let us see the invisible. We are building sensors that use entangled atoms to detect changes in gravity. Imagine a scanner that can see underground, not with radar, but by feeling the density of the Earth. We could find aquifers of water in the desert. We could find magma chambers before a volcano erupts. We could navigate submarines without GPS just by reading the magnetic map of the ocean floor. We are building quantum microscopes that can see inside a living cell without damaging it with bright light, using squeezed light to reduce the noise of the universe itself. So let's step back. Look at your phone again. It is not just a tool, it is a trophy. It is a trophy of the human species conquering the impossible. For thousands of years, we thought the world was made of earth, air, fire, and water. We thought it was solid. Then we found out it was made of ghosts. It was made of uncertainty. It was made of probability. That should have scared us. That should have made us give up on trying to build machines. How can you build a machine out of something that might not be there? But we didn't give up. We learned the rules of the ghosts. We learned how to make them jump gaps, transistors. We learned how to make them clone themselves, lasers. We learned how to make them spin in unison, MRI. We learned how to measure their heartbeat, GPS. And now we are learning how to make them think. We are the bridge between the quantum realm and the physical realm. We are the ones who reach into the cloud of probability and pull out a solid reality. So the next time someone tells you that quantum physics is just theoretical, or that it doesn't matter for real life, tell them to check their Google Maps. Tell them to turn on their computer. Tell them to look at the MRI of their knee. Tell them that they are walking, talking, breathing proof that the quantum world is real. You are a quantum user. You are a pilot of the subatomic. And the ride is just getting started. If this deep dive into the technology of the invisible sparked your curiosity, if it made you look at your gadgets with a little more wonder, please hit that like button. It helps the algorithm, which runs on transistors, find more people like us. And if you want to keep exploring the future, from the mind-bending potential of AI to the colonization of Mars, hit subscribe. We are going to keep taking the complex and making it clear. Let me know in the comments which quantum technology blows your mind the most. Is it the laser, the MRI, or the computer? I'll see you in the next reality. Stay quantum.